Hi everyone, in this video I want to talk about the connection between covariance and independence, the two concepts. So the topic for this video is covariance of X and Y and independence. Okay, so let's review the meaning of covariance. So covariance of X and Y, say if the value is positive, is greater than 0, that means for random variables, value X, if the value of X turns out to be higher, then it's likely the outcome or the values to be realized for Y is also higher, right? That means they're positive relationship. And then the value for X is lower, then the value for Y is also lower, right? That's what it means to have positive relationship. So they're positive relationship. Okay. Good. What it means for them to be negative, for the covariance to be negative, less than 0, all it means is that if the value for X turned out to be higher, then the value of Y will likely to be lower. The value of X to be lower and the value of Y is likely to be higher. Okay? And this is a negative relationship. Okay? Good. Now to talk about the concept of independence. So independence. Okay? Let's say the random variable X and Y are independent, right? Remember the formula we learned in previous video, X and Y are independent. That means the probability of Y given X equals to the probability of Y, right? Which means that X kind of tells you no information about Y. So that's why they're equal. And in terms of covariance, then the covariance of X and Y equals to 0, right? They're not related. They're independent to each other. Okay. And what this is helpful, right? The concept of independence is helpful. It's remember when we calculate variance of X plus Y, we have the 2 multiply covariance X and Y term. So if we know X and Y are independent, that formula will be changed. Okay, so remember the formula, variance of X plus Y equals to variance of X plus variance of Y plus 2 covariance of X and Y. But if we know that X and Y are independent, that means the covariance of X and Y equals to 0. Then the formula will become just variance of X plus variance of Y. Okay? So if we know the 2 variables, the random variables are independent, then you can just drop away the covariance terms. We'll see in the future concepts that this formula is very important because it will simplify our calculations a lot. Okay. One important concept that I want to point out is that if we know 2 variables are independent, if we know independent, then we know the covariance of X and Y are 0, right? This direction, yes. But then the reverse direction is not necessarily true. So knowing the 2 variables, covariance equals to 0 does not imply that they're independent, right? Okay, so remember, this direction is one way. Knowing covariance of x and y equals 0 does not mean that the two variables, the two random variables are independent, right? It's not necessarily true, but this is true. Okay, let me give you two more formulas that we'll use in the future. Covariance of Ax, lowercase letter means a realized value or a constant. So a constant times x, the random variable, and b times another random variable y, and this equals to a times b covariance of x and y. Okay, and then another one, let me switch to here. Okay, the variance of Ax plus by, and this equals to a squared variance of x plus b squared variance of y, and plus 2 times a times b covariance of x and y. Okay, so these two are just a constant times the random variable. Constant times the random variable. And again, these two formulas are useful in our future calculation. Okay, this video talks about the concept of covariance and independence and how they are linked to each other. Thank you for watching. I'll see you next video.